Hi everyone. In the last session, we are seeing how to delete an intermediary node. In this session, we will be discussing how to search for a particular node in single linked list. Right? In order to search a particular node in single linked list, we need to follow some sequence of steps. And these are the three steps that we need to follow in order to delete, in order to search for a particular node in single linked list. And the first step is that we need to check whether the list is empty or not. If the list is empty, simply we need to print some message that single linked list is empty. If the list is not empty, then we need to take some value from the user and we need to check whether the value exists in the single linked list or not. If it exists in the single linked list, we need to print some message that node exists in the list. These are the three steps that we need to follow. And this searching operation is very important in all data structures. And with the help of the searching operation itself, we'll be knowing what is the problem in non-linear, so what's the problem in linear data structure and why we are going with a non-linear data structure, right? So at the end of this session, we will be giving some clarity what is the problem in linear data structures, right? So let us see each and every step one by one. The first step is to check whether the list is empty or not, and how to check whether the list is empty or not. At the time of declaring the program, we'll be taking 3 pointers. In that, we'll be storing what a null in start pointer. When we are executing this search function, if still start contains null, then we need to print some message that there are no nodes in the list. If your start pointer contains null, simply we need to print some message that single linked list is empty. And this condition, how we are framed, see, if start equal to null means, then we are going to print this message. And this condition will be using starting from your create function to what search function we are using this condition. In each and every function, we'll be using this in different way. Right? For example, if you consider display deletion, we'll be giving some message that list is empty. If you consider create function, what we are doing in create function, if start contains null means the node that you want to create and that node address should be stored in start. If you consider insert first and last, if start contains null, the node you want to create and that node address is going to be stored in what? Start. That's what we'll be going, in different cases we'll be using, we'll be going with different logic, right? But in all functions, we are going with this condition, right? So this is what checking whether the list is empty or not. And after that, if nodes exist in the list means, then we need to do some what operation, we need to follow some sequence of steps, and this is the single linked list which consists of 4 nodes in which the first node address is stored in what? Start pointer, and remaining nodes has been connected in such a way that the link part of every node contains address of what? Next node, right? There are 4 nodes are there in the single linked list. Now we need to accept a value from the user, and that value should be stored in some variable, right? So that variable here I'm using a variable called m in order to store the value from the user. In order to take the value from the user, and that value will be storing in some variable called what? M. With the help of scanf function, will be accepting the value, and that value we are storing in some variable called n. Right? So let us make an assumption that the value of n is going to be what? 30. Right? By seeing here, we can say that 30 exists in the list. But how to check whether that 30 exists in the list in the program means we need to follow some set of instructions, and these are the set of instructions that we need to follow in order to check whether this 30 exists in the list or not. And let us go instruction by instruction so that we might be knowing all this for what purpose we are written all these instructions, will be getting some clarity. Here the first instruction is going to be start is assigned to what? 10. Start contains what? 1000, and this 1000 is going to be stored in temp. It's going to be stored in temp. That means temp contains what? 1000. Temp contains what? 1000. That means temp is pointing to a first node, that is 1000. After that, we need to enter into the while, and in this while we have a condition that temp not equal to null. The temp is going to point to the first node, so first node address is what? 1000. 1000 not equal to null means condition is going to be true. If this condition is true means it enters into the while. Inside this while loop, we have one if statement. We can see if temp arrow data means what will be having? Will be having what? 10,000 arrow data that uses what? 10, and that is equal to n. Here my searching value is what? Element is what? N, and n contains a value as what? 30, and 10 is equal to 30 or not, then I am going to check. If 10 equal to 30 means I need to stop the process, but 10 is not equal to 30. Condition is going to be false. If this condition is false means what we need to do? We need to go to the instructions which are there after if part. And what's the instruction that we have after if part? That is temp is assigned with temp arrow link. So what this instruction is saying, we need to move our temp from what current node to what next node. For that purpose, we'll be using this instruction. So temp is assigned with temp arrow link means initially temp is pointing to 1000. 1000 arrow link that uses what? 2000. So 2000 is going to be stored in what? Temp. So temp is moving from first node to what? Second. First node to what? Second. Right? After moving from first node to second node, now what we need to do is we need to check while loop condition. We need to check what? While loop condition. That is 2000 not equal to null. So 2000 not equal to null, condition is going to be true. If condition is true means again we are going to check if part condition. And what does that if part is saying? 2000 arrow data. 2000 arrow data, what we have here? 20 we have. And n value is what there? 30. So 20 equal to 30 means condition is going to be again false. If condition is false means what we need to do? We need to move the temp from current node to what? Next node. That means we need to make a move from current node to what? Next node. And for that we will be going to the instruction temp is assigned with what? Temp arrow link, that is 2000 arrow link that uses what? 3000, and 3000 is going to be stored in what? Temp. So that your temp moves from 2000 node to what? 3000. Right? We started temp from first node and we went to the second node and then we reached to what? Third node. Right? After reaching to the third node, again we need to go with while loop. Again we need to go with what? While loop. 3000 not equal to null. Condition is going to be true. If condition is true means again we need to enter into the while loop. Inside this while loop we are going to check the data part. This time the data part, that means 3000 arrow data, what we have? 30. 30 is equal to n value, that is 30. 30 equal to 30 means condition is true. If this condition is true means what the if part is saying, print node exists in the list and stop the process. Right? We need to stop the process and we need to print that node exists in the list. Node exists in the list. And how to write this instruction, I will be discussing with you. Right? So we find the node in the list. That is one case where we what the user want to search 30 exists in the list or not means the user find that 30 exists in the list and he's got some message that 30 exists in the list. Suppose next time the user want to search for 300. 300 exists in the list or not. 300 exists in the list or not. That is how the user wants to search. Right? So what we'll be doing is same logic we'll be using. We'll be making temp to point to start and we'll be comparing 3000 with respect to what? The first node value. If match is found means we'll be stopping the process. If match is not found, then what we'll be doing? We'll be comparing 3000 with respect to what? 20. 3000 with respect to what? 20. Right? So 300 with respect to 10 we done. Match is not found, and 300 we compared with respect to what? 20. Match is not found. Now we need to compare with the next node value. That is 300 is compared with what? 30. Match is not found, and we need to go with the next node. That is 300 is compared with what? 40. Match is not found. That means final conclusion is node does not exist in the list. But here we need to observe one important point. How many elements are there, or how many nodes are there in the list? 4 nodes are there. And how many comparisons we have done here? 300 with respect to 10, 20, 30, 40. 4 comparisons. That means total number of comparisons we have done is 4. And total number of elements is what? 4. That means one thing you need to observe here that suppose if there are 100 elements are there in the list and you would like to search for some element which is not there in the list, then how many comparisons that we need to do? 100 comparisons we need to do. Suppose there are 1000 elements are there in the single linked list and you want to search for an element which is not there in the single linked list. Then in worst case, how many number of comparisons that we need to do? 1000 comparisons that we need to do. Right? So long back itself we discussed what's the reason for coming to this linear data structures. Right? We are seeing the difference between array and linked list. So there, in case of array memory overflow, and we are facing an issue with insertion deletion. But whereas in case of linked list, there is no memory wastage, memory overflow, and will not be facing any issue with insertion and deletion. But we are not facing any issue with insertion and deletion. But here we will be coming across one major problem in case of single linked list is that suppose I would like to search for an element, but if that element does not exist in the list, then I need to do how many number of elements are there in the linked list and that number of combinations I need to perform. If 1000 entries are there in the single linked list, then in worst case means element does not exist means then I do what 1000 combinations, which is not at all recommended. Right? So you can have a look here. If n elements exist in the list means we need to do n comparisons in worst case. So the time complexity of this data structure is going to be order of n. So you might be getting some knowledge what about this thing in coming semester. The time complexity and is what O of n. Big O of n will be calling it as big O of n. And you'll be getting this clarity in coming semester. And meanwhile, try to remember the comparisons. How many number of comparisons are required here? So if there are n elements, n number of comparisons that we need to do, and it's not recommended. Always, computer science student will look for what shortest path, and that would be what an efficient path. So for that purpose, what we are doing is that we are going with non-linear data structure, where in case of non-linear data structure, we'll be having the time complexity less than this. That means we are not going to do any comparisons in case of non-linear data structures. We'll be going to do less than n comparisons. We are going to perform in case of non-linear data structure. Right? So that non-linear data structure takes less time for searching. That's the reason we'll be going with non-linear data structures. This is one of the important reasons why we are going with non-linear data structures. And this will be an interview question also. Already we have what linear data structure, and why we are going with non-linear data structure means your non-linear data structure searching time complexity is less than your linear data structure. This is the best example. Like 300 I would like to search, and 300 is compared to 10, 20, 30, 40. Match is not found. How many number of comparisons are done? 4 comparisons. How many number of elements? 4 elements. So if 4 comparisons and 4 elements means the time complexity is going to be big O of n. And this is the searching time complexity of linear data structure. And the searching time complexity of linear data structure, non-linear data structure is going to be the less than this order of n. That's the reason we are going with the non-linear data structure. Right? This is the drawback that we have in linear data structures. If you consider anything, this is the drawback that we have. Linear list, any linear data structure, you have this problem. Right? So now let us enter into the coding part of the search function, void space search. I'm declaring some variable into space n comma f is assigned 0. After that, I'm going to check whether the start contains null. If here itself condition true means, then we are giving some message that single linked list is empty, does not enter into the else part. Suppose there are some nodes are there, then it enters into the else part. Inside this else part, the first thing what we need to do is we need to accept the data part. After accepting the data part, we need to store the first node address in temp, and then your while loop is going to be started there. When your while loop has been started, inside this while loop we will be going with some condition, some statement that while temp not equal to null. If that is true, again we will be going with what if part, and whenever this if part is true means we will be making f value as what 1. You already know about this f value. If at all f is what 1 means, then node exists in the list. If f value is not modified means after coming out of the while loop we are checking some condition f value. If that f value is 0 means no node exists with that list. You can observe here if part, what's the instruction that we are taken. If what data is found in the list means, then we will be making the value of f as 1. After that, we are printing some message that node exists in the list. Break means it comes out of the while. After coming out of the while loop, we are checking the condition. The value of f is 0. If at all the value of f is 0 means we are printing this message. However, if we find the data part, then the value of f is going to be changed, and this is not going to be printed. Right? So this is how we are going to perform searching operation in case of what single linked list. In the coming session, we'll be going with the modify operation. Thank you.